Differential equations, exercise 8, sum number 1. The given differential equation to be solved is d cube plus 2d square plus d into y is x square plus x. Now this is of the type f of d into y is capital X, that is f of d into y is equal to x raised to m, where m is a positive integer. So you can see f of d is d cube plus d square plus d, and x raised to m is x square plus x. Now solution to this type of differential equation is y is equal to cf plus pi. That is, the solution has two parts, the complementary function and the particular integral. So let us first find the complementary function. This can be found by equating f of d is equal to 0, that is d cube plus 2d square plus d is equal to 0. This is also called as the auxiliary equation. Factorizing this, we get d into d square plus 2d plus 1 is equal to 0. So on further factorization, we get d into d plus 1 into d plus 1 is equal to 0. So the roots of this auxiliary equation are d is equal to 0, comma, minus 1, comma, minus 1. So we can see that the roots are rational and the root minus 1 is repeated 2 times and the root 0 is a non-repeat root. So the complementary function can be written as c1 into e raised to 0x plus c2 plus c3x into e raised to minus x. So this is the complementary function. So this can be now written as c1 as e raised to 0x is 1, c1 plus c2 plus c3x into e raised to minus x. Now let us proceed to find the particular integral pi. Now the particular integral for this type of differential equation is pi is equal to 1 upon f of d into x raised to m. And here you will have to express f of d as 1 plus phi of d, where phi of d is some other function of d. So pi can be written as 1 upon 1 plus phi of d into x raised to m. Therefore pi is equal to 1 upon f of d, that is 1 upon d cube plus 2d square plus d into x square plus x. Now we can factorize this first. Pi is equal to 1 upon d into d square plus 2d plus 1 into x square plus x. Now this can be factorized as pi is equal to 1 upon d into 1 upon d square plus d square plus 2d plus 1 into x square plus x. Now this 1 upon d means the integral. This can be dealt with later. We will first deal with this part. 1 upon d square plus 2d plus 1. So d square plus 2d plus 1, we'll have to write it in this form, 1 plus phi of d. Now if you see here, there's already a 1. So this expression, we can reverse the order. D square plus 2d plus 1 is equal to 1 plus 2d plus d square. So this will be equal to 1 plus into bracket 2d plus d square. So this is of the type 1 plus phi of d. Phi of d is 2d plus d square. So pi is equal to 1 upon d into 1 upon 1 plus 2d plus d square into x square plus x. So this will be pi is equal to 1 upon d into 1 plus 2d plus d square, the whole raised to minus 1 into x square plus x. Now this expression which is raised to a minus 1 power can be expanded using the formula. 1 plus bracket raised to minus 1 is 1 minus bracket plus bracket square minus bracket cube and so on, where bracket is 2d plus d square over here. So we can expand pi is equal to 1 upon d into 1 minus bracket, that is 2d plus d square, plus bracket square, that is plus 2d plus d square the whole square. Now we will neglect the higher powers into x square plus x. So pi is 1 upon d into bracket. Let us open this bracket. 1 minus 2d minus d square plus, we will expand this using the a plus b the whole square formula, plus 4d square plus 4d cube plus d raised to 4 into x square plus x. Now this would be pi is equal to 1 upon d into bracket 1 minus 2d minus d square plus 4d. Again, these higher powers we can neglect because as d is the differential, therefore the first derivative of x square plus x is 2x, the second derivative of x square plus x is 2, and the third derivative of x square plus x is 0. So d is the first order derivative, d square second order derivative, d cube is third order derivative, d raised to 4 is fourth order derivative. We can neglect the third and fourth order derivative. So pi is equal to 1 upon d into bracket 1 minus 2d minus d square plus 4d square into bracket x square plus x. Now let us open this bracket. Pi would be 1 upon d into bracket 1 minus 2d minus d square plus 4d is 3d square into x square plus x. So pi is 1 upon d. On opening this bracket, x1 into x square plus x is x square plus x minus 2d into x square plus x plus 3d square into x square plus x. That will be equal to, therefore pi is equal to 1 upon d into bracket x square plus x minus 2. D is the first order derivative of x square plus x is 2x plus 1 plus 3 into d square is the second order derivative of x square plus x is 2. So this would be plus 3 into 2. Therefore pi will be equal to 1 upon d into x square plus x minus 2 into 2x is minus 4x and minus 2 into plus 1 is minus 2 and 3 into 2 is plus 6. So pi will be equal to 1 upon d into x square minus 3x plus 4. Now pi will be 1 upon d is integral of x square minus 3x plus 4 into dx. Therefore on integrating every term we get pi is equal to integral of x square dx minus 3 integral of x dx plus 4 integral of dx. Pi is equal to x raised to 3 upon 3 minus 3 into x square upon 2 plus 4x. So pi is equal to x cube by 3 minus 3x square by 2 plus 4x. This is the particular integral.